such series, and will be basically, we just put them on the comment section. People who are joining, just put an introductory message in the chat. And just to walk you guys through what I have done so far, I was able to connect the modem, and I have segregated that whatever POC we were doing yesterday, उसको हमने segregate कर लिया था. I have 80 commands written, इसको expose किया था, और majorly हमने 80 commands क्या हैं that I have kept separately. This is like standard pattern type का मैं follow कर रहा हूँ. I'm planning to keep everything at one place related to all the 80 commands definitions, so मेरे को दिक्कत नहीं हो if I want to scale this further. And then LICHI modem is the one where we have defined what are the modem, what is it, modems, let's put the comment. Here I have exposed as like two methods, and modem commands, empty commands at the time of when you send the command, whatever the message that comes from the UART, that is shown here, and the init command where you are basically initiating all the configs which you will see here. And I kept it here fixed values because for my use case these are fixed values, and someone wants to use the same code, then they will have to modify these values, whatever the for example CPIO pins that is there for my board, they can change it to it for themselves. And then I have written a core where basic functionalities like phone init, checking whether the SIM is available or not, whether the network registration happened or not. And then I've added basic functionality of calling. So first I'll be doing some little hardware work today, so that हार्डवेयर वाला काम निपटा के हम हार्डवेयर वाला काम निपटा के फिर सॉफ्टवेयर पे आएंगे. तो and I hope the screen is visible now, because last time people were saying कि screen size छोटा दिख रहा था, तो I have increased the size of all the, and yeah. All right. Yes, we are done with the hardware part. I think soldering and everything is good. And ST mic is working. Laptop साउंड थोड़ा कम कर देते हैं. थोड़ा कम कर देते हैं. Am I audible? Yes. Thank you. So ये हो गया. नेक्स्ट हम क्या करते हैं ना, let's do some coding. ये तो जो गाना बजाया भाई मैंने, ये हुआ है, क्रेडिट्स भी दे दिए. This is my LICHI phone, and let's go to MVP. What we have done is phone init किया हमने, system health check मारा, phone health check मारा, health check में हमने क्या किया, पैकेट चेक किया, phone data. Okay, ये तो network वाला मारा हमने. Go back by controller. Oh yes, another shortcut that I learned today. ऐसे धीरे धीरे ही सीख जाऊंगा. नेक्स्ट हमारा काम ये है, ये बोर्ड हमने किया है, इसको कर सकें. सिस्टम हेल्थ चेक, डेटा हेल्थ चेक एंड डायल में मैंने इसी फ़ोन का नंबर डाला है, राइट. We should be able to see all of that, and then we can move forward to our screen integration. So let's do that first. उसके लिए हमें ज़्यादा कुछ नहीं चाहिए. This is my cable. By the way guys, every time when I do स्क्रीन जब लिड नीचे करता हूँ, इट्स बिकॉज मेरा लैपटॉप थोड़ा इधर है. ओके, आई थिंक दिस इज द राइट वे. I have a USB connector. Connect this. Or maybe I can put it there, so you guys can also see the hardware and I can show it to you. This is UART. If you are able to see this, just add this on the external and system. This is, oh my god, sorry, I'm new to the streaming world, so let me just, okay, वहाँ पे बहुत सारा कचरा है. I don't think that is looking good for you guys. You just bring it down. Oh, was like is there any way like I can zoom in? There must be some kind of transformation. Oh, crop is there. Right, crop it like 120 pixel. Nope. And from the bottom 20 pixel, maybe 220, maybe here also 200, 250. Yep, that works much better. Okay, so this is the board. We're flashing on this one. Let me put it here. This. Perfect. And if I do IDF top, okay, I'll have to source it first. Source there. Yep. Maybe F top S3 board. All this way. Right. Now I should be able to do this one. Let's make it. वाह, ये कनेक्ट ही नहीं किया मैंने इधर। ठीक ही किया था, नहीं कनेक्ट किया। ये भी मैंने गलत डायरेक्शन में। कनेक्टेड ऑन द UART बोर्ड। काम दोनों में करना चाहिए, बस जस्ट टू बी ऑन द सेफ साइड। यस। Okay, you can see it checked the internet, checked no service online, IPGOnet, read the data, then okay. Okay, so modem issue is there. We're not able to reach the internet. Understand that. Okay, the flash header issue is there. Initiating call, Manual health check. AT command worked. CPI registration. Oh, TSQ we got 1999. So obviously there will be no call because there is no network. Okay. I guess I know why this is happening. Because we forgot to connect the antenna. Technically, I should directly get the call because I just powered it and it must be using the same thing which I wrote. So even when I'm not monitoring, this phone should get a call. This monitor is just serial input where I am reading the behavior, right? But it doesn't matter. It has been flashed with that value. If it is not, then we have a bigger problem. Wait for a couple of more seconds. And thank God, we're getting the call. I was worried. So now the call is happening, right? So what happened was, even though I flashed it earlier, okay. So I had flashed it with the right code, right? And even though the hardware was not connected, still it should have when I connected the right part of the hardware, it should basically execute that same code again and again. When you that's the whole point of embedded system. There is no operating system, right? So your code runs, and if it exits, it exits. So I'll show it one more time. By the end of the call, it exits. So, and let me put the external screen view so you can see both the things. Now you see we got CSQ. This was last time 99.99. That means there is no network. We got the IP also. We are able to ping. So there is network. We are pinging 8888 standard server. The DNS server. HTTP term, we got error. Okay, that's fine. We are not focused on internet part right now. I just threw in that code just to see. Okay, see, these errors are fine. We'll focus on these later. But my main focus was this one. So we got the code. And currently there is no what is it? Microphone and speaker attached to it, so we cannot see the whole end-to-end call, which is fine. I am not interested in the call right now. I'm more interested in adding the touch screen right away and adding my math library that I have written. That I had written for some other purpose, but I think we can reuse that math library. So let's go there, and I'll disconnect this, and we'll come back to me. Focus talking is like this. Only external is like this, right? So maybe I can just make it smaller. Okay. Just a small reminder. Okay, and this we can put below. I can make it Similar, because we're not gonna run code for a while and I want this explorer. So let's get another terminal, bring here. So by the time that resets, what's my documentation here? Hardware inventory, and I can read the readme file of this one also first. So this we had seen in the morning that pen 9 to 14 and 17 to 20 are reserved. So 9, 10, 11, 12, 13, 14 we can see. And then 17 to 20 was also there. So 7, 18, 19, 20. 16 I cannot see. Yeah, 16 is also there. So there must be total 5, 11, 12, 3, yeah, yes. Okay, so display and touch. Display and touch. We have clock, Mosi and Miso, right? Miso. But for this, we will definitely need boards. We can use one of these boards. And I'm doing something like this, maybe. And again, it will always be on that. Need full support. We can use this. Use one of these properly. Even though it will not still give the full support, but still it's much better. Aha, there's a bigger problem. Okay, maybe I can open the sheet and I'll just hardware. I had the inventory. I had that document written somewhere here. Somewhere. These are the code that I wrote, right? I need, yeah, here we go. Display. Here we are. Give to display. But I guess 32. I think website पे better image था. Robo 2.8 inch TFT. That will be more useful for us. Was it this one? No, ours was touch screen, right? Yeah, I got it at higher price, like 900 something, right? No, this one is 2.4 inch. 560. What's the difference between these two? And without touch, we have this. I'm interested in this image. I don't know why Robo.n has done this, by the way. You have a high definition image already loaded on the website. Why are you rendering it at low quality? What's the point of this? It's an image. The main problem is downloading, not the rendering. And this S3 image is definitely downloaded. And this is a much cleaner. You'll see very good image. What I needed from this one is to be sure that we have the same pin mapping. So when I put it on the breadboard and I don't see the pins, I'll still have this as a reference. VCC ground is there, CS chip select, reset is there, VC is there, yes. MOSI, this is a MOSI, purple is MOSI. Clock, then the LED, yes. Then we have MISO, and then the touch screen IC, which is T clock, TCS, T data in, touch screen data in, touch screen data out, touch screen TRQ. And it has attached a register, by the way. I just noticed. Why are they doing that? अब ये कुछ इलेक्ट्रॉनिक्स का फंडामेंटल चीज होगा, मुझे पता नहीं है, ताकि बहुत ज़्यादा करंट नहीं चला जाए गलती से. And they have attached it to the chip select pin and the reset pin and DC. This is the one which whether it is command or data. ठीक है, क्लॉक को भी इन्होंने कर दिया है, उसी को भी कर दिया है. But why will be answered by our dear friend DPD. Okay, no. By the diagram. Okay, resistors attached. This to it. Is it okay? Just in case, because Arduino Uno is a 5-volt board, while most TFT displays 3.3 volt logic, they are trying to protect the TFT pins from Arduino's 5-volt signal. Arduino TFT display, Arduino says 5-volt logic. Okay. You don't need it. Yeah, because ESP32, we don't need it. We are good to go with this setup. You can mount these pins maybe here. It's decently okay. किनारे जगह इसलिए दे दिया हूँ कि IMU डालने का मन करेगा तो डल जाएगा, तो इसको और थोड़ा किनारे कर लेते हैं। तो मेरे को IMU इधर का पिन अलग वाला पिन तो वैसे भी काम नहीं है, तो लेट्स फकिंग पुट इट ऑन दिस। Yep. Forgot to do one thing. But ठीक है, VCC अपने को दिख रहा है राइट, so this board is like this. Oh yeah, SD कार्ड से पता चल जाएगा ना, SD कार्ड इधर फेसिंग है तो अपना भी ऐसे ही है, लॉक लॉक सब सही है, ठीक है। पहले डिस्प्ले ही कनेक्ट कर लेते हैं, टच बाद में करते हैं। तो अपना डिस्प्ले का ये है राइट, वोल्टेज वोल्टेज ये VCC इनको 5 वोल्ट चलेगा। तीनों भी इसमें VCC राइट, यही गलत किया मैंने, क्यों नहीं समझ VCC। Serial peripheral interface. Okay, second one is ground. इसको निकाल रहा हूँ, ये तरीका ही गलत है। ये बना बात सही दिख रहा है, ये भी अच्छा बैठेगा। इसी के बगल में अपना ग्राउंड, ground, and chip select reset DC. For DC also we need 3.3 volt. No, DC is the data. LED will need. LED is sorted with the VC. So we will sort the LED, and LED is the last one, which is 1, 2, 3, 4, 5, 6, 8. 8 पिन यूज हो रहे हैं भाई। 1 2 3 दिक्कत ये है ना कि ये सब चीज यदि गलत हुआ ना फिर दिक्कत है बहुत ज्यादा। ये भी बहुत बड़ा है, तो भी हम लोग शॉर्ट ही कर देते हैं छोटा। ये शुड बी कटिंग दिस, अपने पास है ऐसे वायर, शुड बी यूजिंग दिस दोस, ठीक है। हो गया। इतने में ही हम पावर तो चेक कर ही सकते हैं, ये बैक एलईडी चलेगा, ये कर लेते हैं। And go there. No logic, nothing yet. Just pouring it down. It's working. So this one is fine. Next. Yeah, I think I'm a little bit tired. I'll take a break for like 10 minutes. इसका हाइड्रोलिक का। We're looking at the board wiring. We are done with VCC. We are done with the ground. Need chip select and reset DC and MC. Maybe we'll follow the same, and they both share the same clock, right? If I remember correctly, the readme, right? Clock will go to 5. clock will use white wire, right? The clock is next to LED will use the white wire. Yep. Just write these things. White is up. Then we need mostly master out CLM. What are the pins that they are setting? They are setting clock, optimization. What are the pins they are setting? Clock. These two only, right? And then power and chip select would be different. Need this is confusing, man. You know what? I'll just select 5 different color wires, and then I will consider that as convention and we'll keep going from there. We don't need no इसको फिनिशिंग टच बाद में देंगे, फोकस ऑन द फंक्शनैलिटी वेयर लेयर हार्डवेयर मेंटेनिंग डायरेक्ट एंड टू एंड सारी चीज करोगे। के बगल वाला, चिप के बगल चिप का ही मीसो है, वो वैसे भी ऑप्शनल है। इसके बगल वाला जो है, दिस गाय नीड्स टू बी सॉर्टेड विथ आवर क्लॉक, राइट, विच इज आवर डी के बगल वाला, डी के बगल वाला, डी के बगल वाला कौन सा है, डी के बगल वाला, वो हमने वाइट वाला जो है, हाँ, 325। ये पिन में ना दिक्कत हो गया, लिख लेना चाहिए था। बार बार ऐसे करके देखना बहुत डिफिकल्ट हो रहा है। ठीक है, तो you know what, I have an idea. ये जो है ना, मेरे को बस यही देखना है। Yes. We open it in an app. अच्छा, मैंने पहले से स्क्रीनशॉट वैसे दे रखा था। Just simply give this guy number. मैं बोलता हूँ, इसमें ड्रॉ करने का नहीं होता क्या? क्या फीचर है? अच्छा, ये रहा कलर, मैं डिसाइड कर सकता हूँ क्या? If I can click to white, is this the color? इसको हम बोल देते हैं 1, इसको बोल देते हैं, कितने पेन से टोटल? You know what? इसको 1 बोलते हैं, वो वाले को ज़्यादा easy रहेगा, PCC से भी याद रहेगा। And we have, आपके ऐसे है तो मतलब इधर वाला मेरा 1 हुआ, ठीक है। Now it's easier. And 1 2 3 4 5 6 7 8 9, 1 2 3 4 9, यहाँ तक जो है ये है उसकी 9वां, ये है अपना उसका टच का, क्या हो गया? और यहाँ से स्टार्ट होगा कहानी इसका 10 वाले का। क्या है ये, ऐसा लिखने नहीं देता क्या कंटिन्यूसली? 10 11 14, तो टोटल 14 पेन है। लास्ट वाला हो गया अपना, ये हो गया 10वां। ओके, ये क्लॉक जो है 25, ये 9 था तो 8 है, ये 7, ये 7, ये 10, ये सॉर्टेड है, ठीक है। ये लिख लो 8 10, 7 and 10 are sorted, master or slave in. Okay, so you select a chip and then rest of the 3 pins will be same. So Musi Miso will be same. Musi Miso. And I believe Musi दोनों का जो होगा वही करेक्ट होगा. ठीक है, तो पहले तो क्लॉक सॉर्ट कर लेते हैं. तो क्लॉक कौन सा नंबर पे है? 7वां नंबर पे. 7वां इफ इधर से है, ऊपर से नीचे से आता तो मेरा दाएं से बाएं है. तो वाइट इज वाइट को एलईडी की सही. तो वाइट मेरा जो 7 है वो जा रहा है किसके साथ? 10 के साथ. एवरीथिंग 7 और 10. वो इधर वाला 10. अच्छा हाँ, इधर नीचे और इधर ऊपर है ना, इसलिए कंफ्यूजन हो रहा है. ठीक है, इसका जो 7 है इसके 10 है. तो पहले is your reading, which is power. Properly. ये 3 वायर्स और शॉर्ट हो गए ना. और क्लॉक के बगल में इधर ऊपर तो इधर नीचे के बगल में, मतलब ये जो है 6ठा नंबर. दिस इज सी and it will get sorted with this is chip select, this is clock, data in master or slave in. Let me ask this again. You tell me what pens between CD TDN is basically miso or pussy. Me just two things. I don't want to read option. Mosi is PD in, master out, slave in is PD in. PD in is this one, right? Master out, slave in is PD in is this one. So this was 7, this 6, and it's 14, 13, 6 and 12 will be short. So हो जाएगा हमारा हेड था। हाँ, इट्स सो कंफ्यूजिंग। मेरे को जो समझ में आ रहा है मैं कर दे रहा हूँ, उसके बाद एक बार वेरीफाई कर लेंगे लास्ट में। 10 ये था तो ये 11 ये कोई बात, क्योंकि the trick is when you're calculating, do not worry about the pen, but when you're penning, do not worry about the last if which is I believe C. C will be shared with PD out, which is this. C is what? It is 9. I believe it is 9. 9 and 13. 13. Just do that. I don't care. I don't care. Wait. अभी हमने जस्ट 12 डाला करें electronics engineers, like, how do they do this? I do so EduXC 10. How are you? This is 13. It is the second last one. Makes sense. कैसे हो? I'm just adding the pins, man. This is tough as hell. तो शॉर्ट वाला काम हो गया अपना. Now all we need to do is connect. How you do this? How do I do what? There might be some delay, by the way, in the stream. Because some people were telling me that there is a delay. How do I do electronics? I'm just exploring, man. Like, I'm also new to this. I'm just exploring. Please get done. And chip select will be definitely different for both of them, which makes sense. And data command and density this. Then chip select for this guy. And then this. Also, the pins we sorted, we can be sure that those will be easier to just dump, right? Sorted. तीसरा होगा matter. Voice is low. Okay. Let me increase the volume. How about now? Is it better? तीन पिन को अपने किनारे रखें. इधर जाएंगे सारे पिन्स. इधर तो जाएगा सारा मिल ही जाएगा. यस, थैंक यू फॉर ज्वाइनिंग. बाय द वे, व्हाट डू यू डू? आप क्या कर रहे हो? क्या करते हो? हाउस लाइफ गोइंग? कुछ भी बताओ. The power is anyway already sorted. Avoid consuming GPIO until repeatable. Are you from Bangalore? No, I'm not from Bangalore, but I have lived for some time in Bangalore. I used to work there. Student learning. What are you learning? Learning CAD. What is KiCad? Is it like CAD or some other version of KiCad? PCB design. Oh, nice. KiCad. Man, that's like another level thing that I might do in the future. अभी ऐसा कोई plan नहीं है, but sounds interesting. Are you having fun learning these things? Because that's more important. Like, do you enjoy learning this? This, this. It is open source, yeah. So so you're learning on your own, you mean? Okay. Good. That's nice. Okay, so we have these wires and we're gonna just put these in. You started it, they're good to go. Except yeah. Let's see. So I'm not gonna use black. Let's follow that convention. You can see black to the power running there. Let's use purple. We have purple here. Then we need that, I believe. ये हमने गलत एक्चुअली कर दिया है यहाँ पे. But it doesn't matter actually. चलेगा. अपने को ये दो पिन में दिक्कत होगी. Which is okay. We need this guy here. We need another wire. 3 or something. 2 blue. Windows is good for what you're doing. MacBook is difficult. Oh no, you're totally wrong, by the way, my friend. I used to think like that. I used to think like Linux is open source operating system, best of all. It gives you so many things. And then we have Windows, which is still okay because it gives you terminal. I had a very bad impression of Mac, but when I read about it and I learned more on it about it, I realized, okay, yes, Apple have a lot of restriction due to security concern, but it is still good. It's not like it is based on OpenBSD. If you read about it, you will know it's not that bad. Have these pins also ready, so let me just add a tape to this. OpenBSD was supposed to be the Linux. If you'll read about that history, you will find it very interesting. But apparently, they got into they say legal battles. उसी उधर ही फंसे रह गए. By the time OpenBSD came back, the Linux had already Linux had already covered the market. A lot of interesting history behind it. I think now we are good for wiring. Okay. Clock is 5. 6 is Mosi. 7 is I'm not an employer, neither self-employed. I am just having phone. Doing nothing. Don't take inspiration from me for doing anything. I'm the last guy you should look up to. Power does not. I think we should put the power pin at the end just to be safe. And what we can do is rest of the pins we can put. Yep. So we also switch on, and we need the schematic. So if this is the image and I invert it, but I still want to have that those pin details. I'm pretty sure there's a better and easier way of doing this. अभी मैं बस दिमाग नहीं लगा पा रहा हूँ क्योंकि this is really stupid how I am. I'll think about it. That like इसको invert में भी कर दूंगा मैं. I'll just if I take a mirror image around x-axis, then it's easy to figure it out. ठीक है. ठीक है, that is okay. But still, let's do this way. And we'll add the clock pin first. Clock is 5, right? So our clock is 7. So ours is 1, 2, 3, 4, 5, 6, 7. It's white. So we'll put the white on 5th. How you do this kind of stuff? What do you mean by like how am I doing? The clock is done. Let's call it clock, and let's call it 5. That is easier to remember. And second we need Mosi is 6. Mosi is this one. So 612 is till 6. I read about these things on internet, like that's like I'm still not clear about the question. Like कुछ clearly पूछो मेरे को, मतलब क्या exactly जानना है, तो maybe I'll be able to give the right answer. better answer maybe. This was 7. Okay. So this was 7. 7 is mapped to 5. Is mapped to 6. So this will be it. Okay. Should I like bring that camera here so it is easier for you guys to see what I'm doing? फिर इसको ही घुमा लेता हूँ मैं, लेकिन स्क्रीन मेरे को चाहिए ना. Is it visible? Yes, I think को थोड़ा एडिट ट्रांसफॉर्म करके लेफ्ट को कर दो 0, इसको भी कर दो एंड सॉरी उतना क्लियरली तो नहीं दिख पा रहा है बट चल ओके नॉट बैड. अपने को क्या करना है इधर का एंगल से आई थिंक अब दिख रहा है राइट. No, I'm not an electronics guy. I'm actually a mechanical engineer. I see. Camera not proper at a workbench. I think it is okay now. Transform it maybe 90-degree clockwise, another 90-degree clockwise. Better. इससे ज़्यादा मैं चीज़ें नहीं कर सकता because this theme is just like a fun thing. Doesn't find but ज़्यादा effort नहीं डाल रहा मैं, sorry. Okay, so where will we? Mostly will go to 6. Mostly will go. It went to 6, yes. And next pin we have is MISO. MISO is which number? Our wait, this is MISO, right? It looks like MISO. Yes, this is MISO, 100%. So This is meso. So 9 and 13 is going to 7. 9 and 30 is meso going to 7. Okay. 1, 2, 3. This we with some other guy that is going to 70. Here. Now we are done with the clock and SPIU. This is SPI, yeah, serial peripheral interface, right? Because we are using master out, slave in, master in, slave out, and a clock. So we have done that, which is shared between these two guys, right? तो ये तो हमारा हो गया. इसके बाद एक्चुअल पिन्स हमें डालने पड़ेंगे जो इंडिविजुअल बोर्ड के हैं. ओके, द ट्रबल पार्ट. Chip select. LCD chip select is going to GPIO 8. And chip select is this, which is 3. This is 3. Chip select is going to GPIO 8. Okay. This is my 1. This is going to this is going to this is done. DC is LCD. DC is like data or command 1 is going to 15. So DC is this guy, which is I believe 5, right? 1, 2, 3, 4, 5 हाँ, is going to GPIO 15. और ये है DC is going to GPIO 15, I believe. क्या घटिया एडिटर है यार ये, ठीक है. तो मेरा काम हो रहा है, but why can't I draw on top of it? Why do I need a hand? I don't need a hand. Automatically it's just forcing me to use a hand when I don't want. Is DC and DC is pointed to GPIO. इसको ना there must be an algorithm for this, pretty sure. ये हमारा ये तो हो गया, 3 हो गया, 5 हो गया, चौथा बचा. चौथा वो कर लेते हैं. चौथा इज रीसेट गोज टू GPIO 15. 21. भाई गलत पढ़ लूँगा ना तो ये होगा यूज इंस्टेड ऑफ 6. With what? Okay. Mapping it to 21. This is number 4. and it is going to GPIO 21. We'll call it G21. Right. So this side of the thing is done. Now we need to map the touch part. Touch part goes to CS goes to 2, interrupt goes to 1. That's simple. CS goes to 2, chip select goes to 5. See, this is what I am talking about. Why can't you let me do this? Chip select goes to 2. Chip select, which is what number? 14, 13, 12, 11. 11 maps to 2. Okay, let's do the mapping here only first. And interrupt goes to 1. IRQ is interrupt. I believe last one is the interrupt. यहाँ पे दिख रहा है क्या इमेज में? TRQ must be the interrupt because data in data out है तो वही interrupt होगा. So this one interrupt is the last one, and this save कर लेता हूँ. ये map होगा. You referred from. It is you doing by yourself. Where are you from, by the way? EduXC10. Are you from Bangalore? आप Bangalore से हो क्या? GPIO 1. This is, call it G1. Oh, that's nice. This is G1. So the last one is the purple one. Why do I have 2 wires left? I have only one thing available. Anyway, the last one is the interrupt one, and this goes to interrupt goes to 1. Is all the way done. This is done, and we also have a clock के बगल में है chip select. So chip select goes to 2. You're from Bangalore. Nice. Where in Bangalore? We have clock is done. The chip select is the one remaining, right? Which is number 11, I guess, right? Yes. Chip select 11 maps to 2. is the blue one. Blue one maps to, chip select maps to 2. So this one goes to 2. Let's play again. Which number is this? हमने सारा मैप नहीं किया क्या? I guess LED is not mapped. LED? LED is just yes. Boma Sundara. Yes, nice. Why do I have this wire left? which is the LED wire. But LED wire is which number? 8th number. And LED is the one which is supposed to be the yes. Oh, is it the Moosey? See, it is the Moosey one. Moosey, we had sorted it with that guy, but it will still go to wait, what? Oh yeah. If it is sorted and the other guy is already pinned, I don't need it separately. Which makes sense. That's fine. So this is okay. Should I just remove it? Yeah, better to remove it. Otherwise it will be confusing. It's all okay. I didn't fuck up. Once this is done, तो आप करते क्या हो? Like you are student, you said, right? Learning के क्या? किस क्लास में या कॉलेज में? Where are you? 11th, 12th. Wow. These things are so tricky. I don't remove anything. This is okay. This is okay. That is okay. This is okay. Moment of truth. Whether we fucked up or not, we cannot power it. Undergraduate student. Oh, mechatronics. Hey, nice. Good subject. What are you interested in? Like building something? You know what? Like before powering it in, to now focus on the software side. So we'll go to me focus talking. On this, we'll go to this guy. We'll guy in the corner. Put this guy in the corner. And we'll continue this part. Embedded system. Oh, good. Very good. And there's good opportunity in that field, I believe, right? Or if you pay attention and learn, you're gonna make, because the future is robotics, right? No doubt about it. And if you're good at those things, it will help you a lot in your career. So you can think from that perspective. Okay. Let me just these things what I have written so far. Okay, this is fine, right? I can. Which ID are you using? I'm not using any ID. It's not an ID. It Mm, part working. Now I am gonna start working on the green side of the things. This is not an ID, this is new Vim. I recently picked it up. I'm also not expert in this. Yeah, this was the code. System firmware, touch display, and here I must have written what components did I. Okay. Okay. Yeah. Yes. Dependencies. What me? So far, यार ये बार okay, it's not my window, this is my window. So next step should be we'll focus on display and touch. Modem is done. Core we have written little bit. Touch and display will do. And yep. So for this, let me just split this on the right side. You guys can see. And does this one have? It doesn't. That's interesting. So let me exit this and move this one on the other. Yep. I will close this for a second, and here you can see I need to install two dependencies, right? Just write that where maybe I need ESP LCD your profession in. I used to work as a software developer, then I left my job. The GitHub repo for this. We'll add this idea.py, add dependency. Oh, it is already suggesting the previous one. Yes, we need this. Let me see. We generated that. We'll have to reconfigure idea. So it installed that. Yes. Then we need dependency. We do this. Yes. Dependency. This one we need the touch. Install idea.py. Have you done embedded? Have you done course on embedded system? No, brother. I'm not expert on these things. Hobby. Our dependency got installed, and Let me just see whether everything is building or not. I keep developing this habit where I keep building things when I'm adding or removing something, so I can know at earliest what broke something. Okay, so far good. Now this is good. We have both the components installed here. Do not what I will do. We can first work on the display part. Just create 2 folders inside that. Components, display. We'll create src and include. Okay, touch and we'll call it LICHI display. Same path, display src. We'll call it, what did I call these guys? LICHI phone, LICHI modem, right? We'll call it LICHI. Did I call it display or LCD? Let's call it display. That's more verbose. That kind of makes sense. And we'll also create include yes match. So we have these 2 folders. Okay, write some code. Display display and for display, what are the things we need? इसकी documentation थोड़ा पढ़ते हैं. By the way, thank God you diagram. I will need you when I need you. Let's start. Manual चाहिए मेरे को. Is it the manual? No. Well, खुला था ना मैंने. Is this the manual? Yes. Display. Okay, I'll take a break. I think we'll take a break. Thank you so much, EduXC10, for staying. I hope you have a great day. 2 बज गया. Fuck. Okay, anyway, इसको थोड़ा निपटाना है. external GitHub library. We installed two libraries first. Yep. We can explore it from here also, right? If we have the library. Yes. Because lychee is my favorite fruit. Alright. Just pull it out.
How is beside you?
भाई स्ट्रीम पे ना तो आवाज आएगा ना तो और पूछ रहा है ना वो यू हैव टू बी नहीं यू हैव टू बी रिस्पेक्टफुल यू कैन नॉट से साला वाला Not about loyalty, it's about being human decency. That's my brother, by the way. control, frame rate control, positive gamma correction, and beacon, and okay, maybe we need to one of the core one. Okay. So they do expose some of the header. I've done this. SPI थोड़ा हम लोग एक्सप्लोर कर लेते हैं. SPI सुबह नहीं पढ़ा था, UART पढ़ा था. SPI protocol. Let's ask GPT only. Explain in detail the data. And this board, it will be able to find it. While it does that, we can Google also. This is the library, right? It must, we are using the same library, right? Command R, df.py, and dependency, and we have added yes. Can you saw? No, this is for touch. Not interested in touch. Interested in the display. This one we have added for display. With this, we'll search. GitHub. It is here also. Okay. So link to the datasheet specifications. Yes. And density controller example is also here. And we need to see the source code. They're just giving us to download it from here. Why they not host it somewhere? What happened? Why did I shift from software developer to embedded developer? Just for fun. As I said like before, mainly I'm just exploring what are the things that I like. Okay, so there is a different component registry also, but is it not? It must be on GitHub also, right? Because if you have these repositories, then it must have that. This also. apparently they don't. That's weird. Is it part of like packages? Nope. Where are they keeping the source code? It is giving me download option, but I don't want to download that. I wanted to see it on the. Okay, let's read about, like, we figured out the UART in the morning, and now we will figure out the SPI theory. Robo model 0.8 S. How you study data set? Can you share your learning? I'm also new. I just go through it, and so for example, this is a data set of 245 pages, right? And I'm not interested in all of that. So one of the core things that I look for is bin description, maybe some things related to MCU. But as I said, I'm also new to this whole thing, so I'm still figuring it out. And whenever you are ordering something from internet, for example, this I had ordered, right? So here I can read about it. It says it's a 2.8 240 into 320 pixels, so that is now a number. So yeah, so that could be one trick. Whenever you see any number, try to understand the meaning of that number. What is the importance of that number? This is one rule that I follow. And in the UART we understood, right? So here, yeah, so I was telling you 240 into, let's say this is the hardware that I have to figure out. 240 into 320 pixel. You can just, I'll do it on the call right on the live right now only. It says individual RGB pixel control. It has way more resolution than a black and white, just which makes sense obviously. As a bonus, this display has a resistive touch screen. You can detect the fingers and all. Display has a control into RAM buffering and all that. The display can be used in two modes, 8-bit and SPI. And we are not gonna use the 8-bit part. For 8-bit part, you'll need 8 digital data line pins and 4 to 5 control pins and all that. SPI mode requires only 5 pins, which we have already configured. SPI, data, clock, select and DC. So this is also again number, right? So we are gonna choose PI, and I have SPI data in, data out, clock, select, which is chip select, and a DC, which is a data / command bit, but is slower than it. We are not interested. In addition, 4 pins are required for the touch screen, which is okay. So we know SPI. So यहाँ से पता चल गया कि SPI के बारे में I need to know. So I will go and now I'll read about SPI, what it is. SPI is a serial peripheral interface. It is a way for ESP to talk to your hardware chips using a few wires. So it's like a protocol. LLC this. The display and the controller chip, like this. So now this is also another number, I9341. This is another number, which is the chip. So my chip and this chip will talk to each other. The setting sends the command and pixel to the controller. The controller stores pixel for data and its internal memory. LSL. Think of TFT controller as a tiny GPU like chip. Set drawing window to this. Now here we have these many pixels. Okay. TFT. Okay, I will update my screen memory and write this 240 to 320. Okay. Main SPI drivers are this. Now this is also important. So data out, serial data out, right, is this. Master out slave in, master in slave out, and chip select and ground. MC carries the data from ESP32 to host device, and MISO carries data back from device to ESP32. MC is master out, slave in. It makes sense. Master is our ESP32, यहाँ से device के पास जा रहा है. MISO is वहाँ से इधर आ रहा है. Clock is generated by the host and chip select which SPI device to talk to. Display, you will see non-SPI controls like DC, reset, LED, backlight, power, ground. Touchscreen version, you may also see pins like select, clock. Now this thing is important. Master out slave in of ESP32 have to be in LCD. It kind of makes sense. PI is a synchronous communication. By the way, if you like this stream, do like and share, subscribe. I really appreciate that. One bit every cycle. For 1 byte, you need 8 bits. The clock polarity and the phase experiments. SPI has 4 modes. I generally sleep early, but today I wanted to extend because I wanted to just finish this. I appreciate it for liking it and subscribing, man. Thank you so much for the subscription. Clock polarity is similar to that thing UART where it was always high. Same thing. And CPA is on which edge, whether edge down or edge up. Bye bye, good night, thank you. Thank you, really appreciate it. And if you have friends who are interested in learning similar things, please share my channel to them. Clock polarity and clock phase. Receiver samples data on the rising edge. So there are 2 bits, like 4 combinations, which makes sense, right? What happens when it sends 1 byte is with it to sends many TFT controller that means memory write. The following bytes are a pixel data. For many TFT controllers, 0x2c means memory write. It's not a command, it is a command which says memory write. Following bytes, the following bytes are pixel data. Okay. Pixel consequence, CS goes low, display is selected, DC goes low. This is the byte command. It clocks 8 bits of this on MOSI. CS goes high. The transaction ends. Select goes low. But who will read that? How is that decided? Oh, chip select is okay. So this is only that device. The byte command. Okay. So this goes interesting. Then we send pixel data. This goes low, PC goes high. Okay. The color is goes on. Display has a DC pin. It sends 1 byte. Whether the byte is a command or a data. Okay, makes sense. And set column address. Row address. Write the pixel. Drawing a rectangle. The driver goes with this. Okay, so these are the commands. So as before, what we'll do, we'll write everything in main and then we'll move it to the other. So we'll do here master.h below our this code. We'll keep following this strategy. We'll test it here, then we'll move the things there. ESP panel. This is IDF one. This is not the one we installed. This is not the component. We can do that directly using that. Let's go like this. So we maintain a common structure like a adapter pattern. ताकि कल को बदलना भी हो तो हम बदल लें. ये हो गया box and this is the one we install. If we install, okay. What? While do that, let me just. This is our common interface, and maybe we'll inject this guy there. That's how we had done here. Display main. What's display, right? The display. So UART का bus configuration क्या था हमने? We did phone system, right? हमने UART configuration किया था. Similarly हमें SPI configuration करना पड़ेगा. We did it in C file. I could have done that though. Define it like a constant. Anyway, let's test that. I'm going to close like that. This I need to figure out. It's just because this will define let's call it LICHI time for logging. And whatever pen we map, we need to write that here, right? Because we need those information. So we'll define PD in words because it's a protocol where we define the clock speed, and then we'll define the resolution is 340 320 to 40, right? Maybe PD resolution it is 240 with resolution 320, and then the pins that we used. Pin PDS. Roughly we had used okay, apparently GPIO हो गया है क्योंकि हमने वो सारा उधर मूव कर दिया था, राइट? Let's have GPIO.h. Now it's meaningful. Insert with the CT Constructs Leben comes yes, copy this, paste it multiple times, so we can just do what if I'm at go back. If I go in the replace mode, I can just move here. Go in the replace mode and get this type, right? Mostly let me write here only. This number X. This X. Also number delete end of the word, delete everything. Oh, because I was in caps mode. Because that DE is data check. Then we have reset to us, it was 21. You can delete this. Okay, so far so good. Defined all the chips, and then define the configurations. Maybe we'll define that SPI configuration. SPI bus T, which is bus config equal to dot penalty clock MC is equal to LCD ISO keep everything. This will be LCD ISO. Then what else we have? Second. And then insert node dot about write protocol. Equal to API C. We have HD. This same thing. For size will be next transfer side would be what? Height into width into 16 bits, right? We'll use 16-bit colors, so job you int 16. Right. This whole thing. Okay. So good. This is the bus. Now we need to connect ESP-LCD with IOSPI config. This is again a general bus similar to UART. This general bus. It has nothing to do with actually LCD. General. So how do you support a protocol? The pattern that I'm saying is you basically first define that protocol with chips, then you get into the part which is specific to that system. So in general, mostly ISO and clock, VCC and ground, those things are there. Then when you go to the actual display board, it needs its own command and data specification, right? Select pins, all that. That will define, which will be a IO config. Yeah. Not board, this and this is coming from by the ESP32 P value pen is equal to VTC and that's 36 select, then clock. We have defined like 1 kilohertz, yes, megahertz. I'm like that. I'm sleepy. I'll do some more stream and then I'll command bits are 8, we know. Param bits are 8. SPI mode. We're using the first one, like 4 modes it talked about. Then it comes to 10. Now IO we defined. Now panel control ESP just panel configuration. We in the end need handle only, but this is happening. Pin is equal to pin second. I'll have to look into this to understand why this particular design, like it must be following some kind of design pattern, right? GP and GO. Bits per pixel, we know 16 is this, so now we know that we have a handle, right? ESP panel LT equal to this. The panel has been defined by right these things. Okay, I think my brain is not braining, so we'll continue tomorrow. SPI configurations जो कर रहे हैं, I'm writing the code currently in the main, and similar to what we did for the modem, once the SPI channels are working for both an LCD display, then we'll split it clearly in separate modules. Then actual software engineering problem statement will come. Structuring code, handling the cycle across और कितनी frequency रखनी है किस चीज की, and UI. I'm very much interested and looking forward to writing our own UI because it's a simple math. And see you guys tomorrow. तब तक के लिए this we did today. This is the final thing, and we were able to do this filing. I have not tested it yet. The sole reason was I wanted to be in a sane state to verify all the pins, because display boards are kind of sensitive. If you put in some high voltages into that, it can create a problem. Just delete this, write this, and maybe just see if it is compiling. If it compiles, I'll commit it here. Yeah. And this one. Delete this basic and we'll pick from here, and I'll see you guys tomorrow. Take care. Bye bye.